I'm R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we discuss the topic on skin effect for the course Electromagnetic Fields and Waves. So, wave equation for a conducting medium, we considering a conducting medium having conductivity sigma and the incident wave at the conducting medium having two field components. One is the electric field Ey and the magnetic field Hy, and the wave is traveling in x direction, we are assuming. And the right hand side we have wave transmitting into the conducting medium, and the opposite side we have the reflected wave. And the boundary of the conducting medium is given by the thick dark line. And now at x equal to 0, that is at the boundary of the conducting medium, the x value increases positively into the conducting medium. And now we are assuming the wave penetrating into the conducting medium as the transmitted wave. And we can write the expression for electric field Ey is E naught e power minus x by z e power minus j pi divided by del. And this value del is equal to root of 2 by mu omega sigma. At value x equal to 0, if we substitute x equal to 0 in equation number 1, we get Ey is only E naught. And this is the amplitude of the field at the surface on the conducting medium. Now, del has the dimension of distance. So, at a distance x equal to del, the amplitude of the field becomes E naught e power minus 1. And e power minus 1 can be written as 1 by E. Then the electric field Ey is equal to E naught into 1 by E. So, Ey decreases to 1 by E, that is 36.8% of its initial value, while the wave penetrates into the distance del. And this del is called skin depth or depth of penetration or 1 by E depth of penetration. For example, consider the depth of penetration of plain electromagnetic wave incident normally on a good conductor such as copper, and we know angular frequency omega is equal to 2 pi f, and the 1 by E depth or skin depth becomes del is equal to 1 by root of f sigma pi mu. And for copper, mu r value is equal to 1, and so that mu r is 1.6 mu h meter per meter, and the conductivity sigma is 38 micromole per meter. And putting these values in equation 3, the skin depth equation, we get for copper the skin effect is del is equal to 6.6 into 10 power minus 3 by root f. And this del is equal to 1 by E is known as depth of penetration in meters, and f is the frequency in hertz. So now we are evaluating the skin depth for various frequencies. At 60 hertz, it is 8.5 into 10 power minus 5, and for 1 megahertz, it is 6.6 into 10 power minus 5, and for 30 gigahertz, it is 3.8 into 10 power minus 7. And at 6 gigahertz, the depth of penetration is 8.5 nanometer. So, the penetration decreases in inverse proportion to square root of frequency. And this phenomenon is often known as skin effect. So, at high frequency, field is damped out as it penetrates a conductor in a short distance than a low frequency field. In addition to 1 by E depth of penetration, we can speak of other depths for which the electric field decreases to an arbitrary fraction of its original value. For example, consider the depth at which the field is 0.01 or 1% of its original value, and this depth is obtained by multiplying the 1 by E depth by 4.6 and may be called the 1% depth of penetration. And phase velocity is given by the ratio omega by beta. In the present case, beta is equal to 1 by del, so that the phase velocity in the conductor is Vc is equal to omega del is equal to root of 2 omega by sigma mu. and this 1 by E depth is small, the phase velocity in conductor is also small, and the ratio of velocity of a wave in free space to the conducting medium is the index of refraction for the conducting medium. And we observe that at lower frequencies the index for conductor is very large, and the wavelength lambda c for a conductor is given by 2 pi del, where this lambda c and del are the same unit of length. Hence the wavelength in the conductor is 2 pi times 1 by E depth, and the values of 1 by E depth, that is 1% depth, wavelength, velocity and refractive index for a medium of copper are given in the table for 3 frequencies. And the penetration depth is always inversely proportional to the square root of the frequency. So a thin sheet of conducting material can act as a low pass filter for electromagnetic waves, and this is the table which represents penetration depth, wavelength, velocity and refractive index for the material we have taken as copper. And wavelength in free space for various frequencies, it is 5 millimeter, 300 meter, 10 meter, and 1 by E depth is given, and for smaller frequency 1 by E depth is large, and higher frequency it is small, and 1% depth is also given. Wavelength is 5.3, which is greater for small frequencies. We know wavelength and frequency are inversely proportional, and velocity of conductor, index of refraction is also given. So we can understand the relation between the various parameters of a electromagnetic frequency when traveling in conducting medium in terms of frequency. Thank you.